I'm Nordic Sales Director at Cellink, and I have been with Cellink for quite a while, almost since the start. So I've been seeing the transformation from nothing to where we are today, basically. And I will try to take you with me on this journey to show you what has been done and where we are today, and also where the future is. So starting off, we saw a big possibility because there's a big risk out there with drugs getting stuck in clinical trials, and it takes way too much time, and lives are going lost during this development phase. So looking at this, there's also a cost factor. So time is money, and the cost for a development of a drug is huge. So if researchers can get more accurate data on an earlier stage, this cost can be reduced. And that's what we believe in. And at Cellink, we always say that if you should fail, you should always fail as early as possible. Therefore, Cellink developed a bioink to get 3D cell cultures. So this bioink provides the cells the 3D environment. And Cellink is actually the first company in the world to commercialize this kind of bioink. This bioink is made from different materials, and I will show you during this presentation what kind of materials that can be used. And the main reason is to get the cells to behave like the native environment. The first bioink worked perfectly for mesenchymal stem cells and chondrocytes, but there is no general bioink, and that was something that we received from the market, basically, from researchers. So we started looking at how can we develop tissue-specific bioinks. That has led us to where we are today. So until today, we have more than 50 different bioinks, and we are continuously developing this further because we will never stop with thriving. So how do we do when we develop bioinks? We look at the first step of selection of biomaterial. So here you can have different components depending on the time frame of the study, basically. So you can have synthetic polymer, natural polymer, or ECM. Then you look at a lot of different components, such as printing fidelity and making sure that the cells feel good. Our main parameters are, of course, printability and cell interactions. Because if the material is not printable, we don't have a business model that holds up. And if the cells are not good, then we won't have happy customers. This is just one example from a partner of ours that was developing their own bioink. And you can easily see that the increase of alginate across the lines makes it more printable. And this is not only to get finer lines, but you can also create more advanced structures, such as an ear or sheep meniscus on the pictures. And they also stay over time, so it's a stable material as well. Developing further, we looked at how can we make this even more in vivo-like. One approach is to actually take ECM. So here we have taken animal-derived ECM. And the ECM provides the cells with the most important molecules beyond structure and biochemical support, and everything to create the in vivo-like structure. The other approach is to develop tissue-specific bioinks by taking specific proteins from different tissues. So for example, this can be more attractive to researchers that aim for clinical trials, because this is more defined than actual ECM. When you take a specific protein, you know exactly what is in there. If you take an ECM, the full ECM from a tissue, you don't know what you have. But as you have understand now, we are focused on bioinks. And that's what we started with. We started with one bioink only, that the founders opened up a web shop. They put up the bioink. They sold out the first day. Great. But there's a limited market. So the founders looked at the market and realized that there's a limited market for bioinks because the bioprinters were super expensive. They cost, as you can see, up to $200,000 and more. So the way to go was to democratize 3D bioprinting, both because then we get a bigger market for bioinks, but also because we never know where the next innovation will come from. It might come from a completely anonymous country. So they decided to start manufacturing 3D bioprinters. And this was going to be super easy to use, user-friendly, and cost 1/10 of the price that were for the existing instruments. So they launched this system that you can see on the picture for $4,999 US, simply so that professors could buy with a credit card on the spot. And this led to quick deals and upscaling, basically. So what Cellink is good at is taking in customer feedback and market feedback in general. And this led to a third generation, that is the BioX, and this has been the revolution for tissue engineers, cell biology, or regenerative medicine researchers. And I have a short video that explains it, and this is like no other system, basically. And it doesn't only look simple, it is that simple. And I believe that anyone can print within 10 minutes. That's how easy it is. And if you don't believe me, I will more than host you in Gothenburg, and I will show you how it's done. And one of the functions that was mostly desired was the modular system, that you can print anything on one system, instead of buying 4 different systems for 4 different materials. So we developed a modular system that you can print anything from water to polymers, basically. And this is not only meant to be a promotional video, but another reason behind the success of Cellink is that we're such a diverse company. We have more than 27 nationalities, and this was made quite a while ago, so I guess we're more even now. And we're spread out over the world, and we actually believe more in hiring talents than filling up open positions. And that's one of the biggest reasons we're where we are. And talking about where we are. So until today, we have reached more than 700 labs. So the technology is not new. Yes, it's new, but it's widely used. We are more than 160 employees. Back in a year ago, we were 50, 60 employees. We're spread out over the world in Boston, Blacksburg, Gothenburg, Kyoto, Stuttgart, and Freiburg. And we have the technology in more than 60 countries already. And this is even though we started in 2016. And I love this slide because it talks for itself, but also because it's such a proof that 3D bioprinting was boring and no one did it. And Cellink actually achieved on making 3D bioprinting a little bit sexy, because nowadays there's a huge increase of publications in the field. And we're so happy to see this, because that shows that we have actually managed to democratize this. And a few of the users or partners' publications are that we have a partner in Newcastle that was working on printing a cornea, and the organ donor shortage for corneas are insane. Also because the vision impairment treatments are causing this to be even more and more victims, or so to say. So they are actually aiming for clinical trials within 2 years. It's soon. Another partner in Plymouth are working on skin. And I will dig deeper into this soon as well, because this is one of the applications we are focusing on at Cellink as well. But they are focusing on developing skin for testing cosmetic products. But there's also a huge market for burn victims. And that's why this technology is needed. And I guess some of you saw the news from Israel when they printed the heart, a miniature heart. This was actually a partner that was before that. And there's so much done that the news can't keep up, basically. And moving into the applications that Cellink has been selected to focus on. So starting off, Cellink started with one bioink, as I said. This is a study done by that, or with that bioink. So the partner decided to take the human azochondrocytes, mix that inside the bioink together with cell culture media, because the cell culture media are what provides the cells with the nutrients. And the bioink is supposed to give the 3D environment. Then you need a blueprint. And a blueprint is what provides the machine with a pattern, where to extrude and how to build up the model that you want. Then you print it out, you cultivate, and then it's done. We don't only want to print out and then make sure that everything is fine. We want to make sure that it's actually successful. So you can do that with a simple live dead staining. And what is mostly important here is that from day one, you can see that the cells are homogeneously distributed inside the construct. And then over time, they start to making these clusters that they actually should. And then you can see cells per scaffold. That's increasing from 14 to 28 states. So they are also proliferating, which is great. But we're not happy with that, because we want to see more. So we want to make sure that they are actually producing what they should. So here we stain for glycosaminoglycans, and you can see that they are increasing over time as well. So that's good, but it also gives a really nice expression of collagen, which makes it a really nice model. Next area is skin. And as I said, this is really hot on all kinds of markets. And it's perfect, because skin is built layer by layer, and that's how a 3D printer works. So we wanted to focus on the dermis, and I will show you on this slide. So we have different cells and different concentration of cells to mimic the different layers of dermis. Once again, you need the blueprint. You take the bioink together with the cells. And for the papillary dermis, we have a high concentration of fibroblast. For reticular dermis, we have a low concentration of fibroblasts, and then we have keratinocytes on top. We print those in well plates, culture them for 2 days, then we flip them into the inserts, simply because we want to expose them to the air-liquid interface to be more in vivo-like. We want to make sure, once again, that the cells are proliferating and creating what they should. But most importantly, you can see from day 5 to day 14 that the cells, or especially in this case fibroblasts, are starting to create the networks that they should. And also the keratinocytes are homogeneously distributed, and then they start to create these clusters that they should. Next application is a proof of concept we did with a pharma company. And they simply took primary cells from patients, and then they tried to culture them, but they didn't survive for more than 2 days because primary cells are a mess. And they wanted to see if they can survive longer in a 3D cell culture. And they simply did. They were surviving for 2 weeks, and then we ended the experiment, but the cells were still surviving for up to 6 weeks. And most importantly, they are having the morphology as they should, and they start making these clusters once again. I mean, now I'm showing initial data. This is still early phase. There's more needed, and there's more coming, but it's a really good start. And another case was, I don't know if you can see, but I hope so. This is printed iPSC-derived cardiomyocytes. They were not beating post-printing, but after printing, they actually started beating. And what is most amazing is the second video on the right, because then you can see that they are synchronized. So they are actually starting to communicate as well, which is quite cool. So we can print cells, we can create scaffolds, we can create tissue-like models, we can create a lot of things, but there is a challenge, and the challenge is that when you create bigger structures, you struggle with diffusion of oxygen and nutrients, so you need vasculature, and the vasculature is a big step. There's different approaches, but one is to create a simple way of vasculature, basically. So we worked on a product because it was, once again, professors came and said, we need this. So yeah, okay, we'll take a look. And here's a short video that will explain further. And for those who didn't understand, those green dots, that's cells flowing. It's so cool. And this is just the start. And we have developed a lot of different techniques and products. But combining all this, there's so much possibilities. I mean, as soon as I meet cancer researchers today, they say that they are doing so amazing stuff, and they are, for sure. But there's so much more that can be done. Just when I mentioned that we can study cell-cell interactions, 90% of the researchers don't believe me. And here we can actually see cell-cell interactions together with any kind of cell flowing inside and see how they start to migrate. It's insane. And one more insane thing is this. This is a partner that was featured on Science Cover recently. So they printed the smallest part of a lung, the alveola, and they could actually show how they could oxygenize deoxygenated blood with this technique. So inside here, you don't have, or you have oxygenated blood. Outside, you don't have oxygenated blood. And this oxygen could actually diffuse out to the outer layer. And this is a big step. And this is going to push the field even more forward. And with that, I am happy to receive your questions.
Thank you, Daniel. I'm so inspired. I feel like I'm also very enthusiastic when it comes to cells right now. I don't know. They are beautiful.
We're looking for talent.
Yeah. Please have a seat. Okay, we have a few questions here, and one of them came in quite early. Perhaps they got the answer as you were talking, but we can still cover that one. What is ECM?
ECM is extracellular matrix. It's a protein, basically, in the body. It's a natural thing.
Where did your journey in all this start?
So I was working in sales in a distributor company, and then I was approached by a recruiter, and then I met two of the founders, and I simply said yes to joining.
Great. What convinced you? Did they have these nice pictures then as well, or?
They told me what they were doing and what the products could do, and I didn't believe them. But when I saw it, I was like, yeah, this is something I need to do.
Obviously, you have been growing as a company, and one of the questions from the audience is, how many researchers do you have in your company?
Good question. So, we have different kind of researchers. So we have R&D for software, hardware, and bioinks. But I would say most of the research is in the bioink department. So that's roughly 20 people.
Yeah. And we talked about it earlier today about co-creation. How important is it actually for you to work with people outside of your company?
Super important, because we never develop a product without a collaborator. As soon as we are approached by a professor or customer or partner that want us to do something, we always check with other users, and then we co-create together with the user. Because we will never be the ones having the answers for everything, and our users won't be the ones that have answers for everything. So together we can make amazing things.
You talked about that you had a great diversity, and you have people from all over the world helping you in doing what you're doing. How do you find those people, or how do they find you?
That's actually a luxury. I mean, we have got quite a good spread of media, so we're quite well known in the field, and we have a lot of applicants for different work positions, but then we meet a lot of people. As I am out traveling now, so I might meet someone talented. But that's how we discover.
Another question is about what is the most challenging issues in your application?
That is a tough one.
Yeah.
Super tough one. I would say the most challenging is to get more people on board, because we know what we are aiming for, and we know that we have a lot of partners that are joining us on this journey, but looking at something completely new, it's hard to get everyone on board.
And I'm thinking about all this. This is what you're doing is you're creating things that we normally have naturally as humans, and now you're creating it through printing. Do you have any like ethical obstacles in what you're doing?
Yeah, I mean, the first day I joined, I asked our chief scientific officer, what can be done? What can we print? And the answer was basically anything. It's possible, but there's a lot of ethical rules and things that we need to follow, and you need to have FDA or CE certified materials and everything. So there's a long process of going through all those steps, but never give up.
Yeah. Do you get help? I mean, how do you get that kind of knowledge to your business as well, if this is one of the obstacles for you to actually move forward?
Together with the bright minds of researchers, because they have been through that journey, they can support us on it.
You said when you started your speech that, well, in the beginning, they found out that, well, this is a great possibility to do this. How do you know that you come up with a sort of a great solution or a great possibility?
I have actually asked the same question, and the answer was, yeah, I've been lucky, but I don't think so. I think when you are a visionary, that you can see that this is going to be something big. You have a feeling and you follow that feeling. Political answer. Political answer.
Well, I guess it's not that easy to answer either. So, we have one more question about the future here. When do you think we can go to organ shop and buy new eye or heart? Would it be in close future?
Depending on what tissue, I would say. I mean, for corneas, they are aiming for clinical trials within 2 years. And that's also an external organ, such as skin. So those two tissues might be close in the future. I can say something like within 5 years, maybe. Other more complex tissues are quite far ahead, but still, within research, it takes time.
You said also during your speech that you were able to make this sexy. I guess that could be a challenge sometimes with research, no offense now. I mean, you have a great idea, you develop something great, but then how do you communicate it? How do you make it sexy? Do you have the answer to that?
I would say it's about commercialization, having an eye for what people want, even though they don't realize what they want. I mean, for example, Tom Ford was asking the market, what do you want? And they said, faster donkeys. That's not what they actually wanted, apparently. There's about having an eye for it.
This morning, we also talked about the change of business models. And we saw actually a transformation here. What is your business model?
The business model is to get as many systems out there, to get as many researchers working on this technique, and then working with those users together, because we don't believe in just supplying a hardware or bio-ink, because we actually believe that researchers' success is our success.
Yeah. What about the money? How do you get the money to all this? I mean, I realize this is not done afternoon coffee break or something.
I mean, as I was touching base on before, what we want to actually sell is the bio-inks. All of these kind of businesses is about consumables. The hardware is a way to get consumables out there.
Okay, another question about like future possibilities. Would it be possible not just to print body tissues, but perhaps medicine as well in the future?
Really good question. There is actually companies that want to print special tablets, so printing pills, because nowadays you overdose or take too small dose, So if you can personalize the pills or drugs, that's a huge step. So it's ongoing as well.
Exciting. Now a question, I think this has to do with ethics that we mentioned somehow, and also the regulations, of course. What is the source of human cells, and how can you upscale human projects?
Different from different tissues. I mean, you can take fat cells and then you can make them to iPS cells. There's donors. That's up to the researchers that use our technology, more or less.
Okay. Well, you went on board on this project a few years ago, and I can see your enthusiasm is on a high level. If you just sort of look at 10, 20 years from now, where will we be when it comes to 3D bioprinting?
I hope that we have started printing skin for burn victims, because that's something that is needed urgently. That's what I really want to see. Of course, I want to see more tissues being implanted as well, but skin is what I think can actually happen within that time frame.
Thank you so much. I will also give you a gift for being with us today. And I know you're staying for the evening as well.
Yes.
Yes, so at Get Together, please catch him and ask him more about all these things. Here's a gift from the Sundsvall region. You have some cozy time now during autumn.
Thank you very much.
Enjoy it.
Thank you very much.